Okay, so we are back to my channel, and I'm going to show you what we are going to be doing today. So today we're going to be doing using volume formulas. If you remember, we explained them before, and now we're actually going to be using them, which we did use them in the other one, but I don't know, that's the way they're divided up. If you still have this from before, again, I'll include it in the link this time, but it's the same one that we had before. There's actually a few extra that we will be using that I'm going to add on. They're in the worksheet itself, so you don't have to, but you should know this one. So area of a triangle, and that is 1/2 base times height. Okay, so I think they write it A is equal to that way. And then I think it was volume of a sphere, just to make sure it wasn't the area. Well, yeah, it has to be the volume if it's a sphere. So this is the other one that we're going to do. So I'll leave this up in just a second if anybody needs it. Again, it's in the actual worksheet, so you won't have to worry about it too much, but that is 4/3 pi r cubed. These formulas start to get really messy, really similar, and it's just something that happens, and I'm sorry, but you just have to get better at them. Okay, so I'm going to set this aside. I won't be using it anymore. I have these formulas already, and again, they're in the reading as well. Okay, we're going to get started using volume formulas. So, let's see, this is where it ends. I just want to make sure that I push this up when we get to cones. Objective. In this lesson, you will, use volume formulas. I think I left off the word use, but use volume formulas for cylinders, pyramids, cones, and spheres to solve problems. Okay, in this lesson you will study how to find the volume of a three-dimensional object using formulas. Not all of the objects in this lesson are perfect cones, cylinders, pyramids, or spheres, but volume formulas still provide a reasonable starting point for calculating these volumes. So all that's saying is, like in the real world, you're probably not going to find a perfect cone or a perfect cylinder. It'll have dents in it, it'll slide off at the top, it might be curved at the top instead of flat. But it doesn't matter, it still gives us a good starting point, and sometimes we have to combine maybe a cone and a cylinder, or half of a sphere and a cylinder, and so forth, to be able to get our true outcome that we need. Okay, cylinders. If you remember, or if you have that sheet that has the formulas, the formula for the volume of a cylinder is pi r squared h. And let's put the formula to use. So here's an example here. Now, I'm going to go ahead and tell you that right here, if you're following along on the tutorial, I skipped activity. So there was the activity page, I just kept clicking, and now I'm at example here. And this is example number 1, because there's actually going to be another one after this. Okay, it says, what's the volume of the cylinder in this diagram? So using the formula, this is radius, which is r. This is your height, which is h. And that's all you need for the formula. So the formula is going to be pi times 6 squared, because that's representing your r, times 13. You put this into the calculator. So I'm typing into the calculator 36 times 13, and I get 468. In the previous lesson, we would multiply it by 3.14, but here in the answer, they left the pi symbol, so that means you do not multiply by 3.14, sorry. That's your answer, and that's the one that you'll select. Now, I don't like that they don't have it on this worksheet, but there is one more example that follows this in the tutorial. And I'm going to call it example 2, and just in this white space, I'm going to draw it in. In example 2, they said, what is the height of the cylinder? Okay, and I'm just going to do a quick sketch of what they give us. They give us a cylinder that looks something like this, and it says 6 centimeters for the radius. And then it says that the total volume they already figured out was 904.78 centimeters cubed. Okay, so the work for this is actually very simple. It looks confusing because how are you supposed to find the height? The height is here and we don't know what it is. Plug everything into the formula except for h because that's what you're looking for. So usually we have v equals, but we actually already know what v equals. So this is what the formula is going to look like. 904.78 equals, and then we take pi r squared h. So we put down pi. We know what r is, it's 6 squared, but we don't know what h is. So that's what it looks like. I'm going to go ahead and change this to the number 36. So now I have this. 904.78 is equal to, I'm going to change this to 3.14, so when I type it into the calculator, I don't have to put in the pi symbol, because most of you guys probably don't have calculators that you can put pi in. If you can put pi, you would not have to do 3.14. You could just type in the button. So I'm actually going to change the pi symbol to 3.14 and change this to a 36, and this is 8. I'm going to go ahead and multiply these out. Actually, I didn't multiply them out. I just kept them both under there. So I've divided by 3.14. I divided by 36. If I do it to one side, I have to do it to the other side. Okay, that gives you h. H is, and it says to round to the nearest whole number, h is going to be 8. Okay, so then we get to cones. So after this, we get to cones, and the volume for, the formula for volume of cones is right here. They give it to you. So you use this as the basis for any volume calculations on objects that are shaped like cones. So we don't actually use it until the next page. And I forgot to mention, but this time I printed them out front and back. So if you do the same, it'll look like these. If not, again, they'll just be separate pages. So the next page will look like this. There's a cone at the very top. Okay. So, once again, I skipped activity, so I'm going to put that here. Now, feel free to do the activity, and if you get stuck on it, you can always, I've had some, like, take screenshots of it or take a picture and then send it to me on the Remind app and say I'm stuck on this part, and that's fine. I just choose not to go through it in the lesson. It just would make a very long video, and I don't want that. Okay, this is going to be example number 2. So I'm actually going to start with example number 1 up here on the white space because, again, they left it off. I'm not going to draw the picture, but there'll be a picture on your screen, and we know that the volume of a cone from the front is 1/3 pi r squared h. And it said, find the volume given the following pieces of information. So we just fill in all the information they gave us. They gave us that r was 5. Actually, they gave us that that the diameter was 10. So you have to half 10. Half of 10 is the radius, which is 5. Then we square it, and the height was 18. I literally just take and type all of this into the calculator except for pi, because if you look, they left pi in the answer. So you're going to take and you're going to multiply 25 times 18, and it's going to give you this. Oops, not 200, 450. Okay, now you have 1/3 of 450 and pi. All you're doing is you're dividing by 3. So take 450, divide that by 3. And again, I'm just trying to help those who don't have a calculator that does the calculations pretty well. So if you can't put in a 1/3 in the calculator, you would just do 450 divided by 3, and it's going to give you your final answer, which is 150 pi. And this was volume, so if you wanted to put units, you could, but you can just leave them off. That's not what it's looking for. Okay, so now we're going to move on to example 2, which is drawn in, thankfully. It says, what is the radius of a cone in the diagram? So they give you this information. They give you the total volume, and they give you the height. We're going to do it the same way we did the second example and the other one. It says, round your answers to the nearest whole number. So given the values in the cone, you're going to solve for the radius. So here is the volume. Here is the actual here's the volume formula, sorry. And here is the actual volume that they gave us there. 1/3 pi r squared times 12, because that's the height. So I'm actually going to do my work out here in this white space because you don't see it. They just go straight to r. So this is what I would do. I'm going to go ahead and find 1/3 of 12, which just means to divide by 3. So 12 divided by 3 is 4 pi r squared. I'm trying to get r by itself, so I'm going to divide both sides by 4 pi. That cancels, and you get that r squared is equal to, and then here is where it gets a little bit complicated. If you have a calculator that you can push the pi symbol, you can just type in this divided by 4 pi, and it's going to give you the answer. If you don't, you're going to change this to 4 times 3.14. When you get that number, it actually turns into 12.56. So now all you have to do is 201.06 divided by 12.56. That gives you 16.00, and then it keeps going. I'm just going to round to 2 places. I'm going to find the square root. You should know what the square root of 16 is. That's 4. So r is about 4 units. Okay, we're going to move on to pyramids. So the formula for the volume of a pyramid is, if you don't remember, 1/3 the base area times the height. So we have to find the area of the base first, whatever that may be, and then we multiply by the height. So that's the formula. Oh, and 1/3 of that. Okay, there is an activity, and again, I'm going to skip activity. And I'm going to go straight, like in the tutorial, just keep going. And this is the only example they actually give for this pyramid, so I don't have to put example 1 on there. So let's look at it. Begin by finding the area of the base of the pyramid using the triangle area equation. So we wrote this on that other worksheet, but the area of a triangle is 1/2 base times height. Okay, so now if we know that, basically I'm finding this base area first. They actually take it and they redraw the base over here separately, which is awesome. So now the base of the triangle is 5. The height of the triangle is 4. And we're talking about only the triangle that was sitting flat on the bottom. 5 times 4 is 20, and 1/2 of 20 is 10. So now, what is the area of the base? 10. So we come down here. Next, use the pyramid volume equation. The volume is equal to 1/3 times base area times height. We just figured out the base area was 10, so now we're going to apply that over here. The height of this picture is 12, so we'll put a 12 here. 10 times 12 is 120, so then 1/3 of 120 is a fancy way of saying divide that by 3. 120 divided by 3 will be 40 cubic units. So that's the answer to that. Okay, so now we're going to move on to the last part. The last part is spheres. Okay, the volume of the sphere is given by the following formula. They actually want you to go to They actually want you to click on like some link, and it takes you to the discovery of a sphere. If you want to click on it, if you're the type of person that you need to know why it's 4/3, why is it not 1/3, and so forth. If you want to click on it and get a better understanding, you can. But basically, all that's going to come from that is you're going to discover that the formula is 4/3 pi r to the 3rd. Now, it's given to you also down here, and we wrote it on that list of formulas that we had already. Okay. Just so you know, there is an activity that comes after this page, which again, I skipped the activity. If I could spell it. Okay, what is the volume of the sphere in the diagram? So here's the sphere. Here is the information they give us. It says find the volume of the sphere by given the radius. The radius is 3. What you do is you take 3 and you replace it right there. So 3 cubed. And you have 4/3 and you have pi. 3 cubed is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So I replace all of that with 27. Now, you're going to do 4/3 times 27. I'm going to go ahead and tell you, if you don't have a calculator that you can do that, you just take it in steps. You can do 4 times 27 first. After you get that answer, divide by 3. And you don't have to do it in that order. You could do, I would do it this way, 27 divided by 3 first, which is 9, and then 9 times 4, which is 36. You don't do anything with pi because they actually keep pi in their answer. Okay, so now we're going to keep going to scaled volumes. So scaled volumes. Volumes of solid figures scaled by a factor of k to the 3 when a scale factor k is applied to each dimension of a solid figure. Okay, this is just a fancy way of saying, and if you've been like actually keeping up with the tutorial and not skipping around too much, you realize like sometimes you're finding the volume of a cone, but it's a scale factor because you're actually finding it like on a massive scale, because it's a roller coaster ride or it's a building or whatever. So if that's the case, sometimes you have to multiply it by the scale factor. You have to enlarge it. So this goes back to when we did transformations, when we had a scale factor and we dialected it to a higher amount. But it's actually really simple. Whatever the scale factor is, since we're talking about volume, you are always going to put a cube on that scale factor. That's all that is. So anytime they give you a scale factor, put a 3, like a little 3, a cube on there, and that's going to give you your actual number that you multiply by. So let's look at an example here. So for example, a rectangular prism with a volume of length times width times height is scaled by a factor of k equals 2. It will have a new volume of, you take the volume and you multiply it not by 2, by 2 to the third. 2 to the third would be 2 times 2 times 2, which is 8. So that would be your new volume. Whatever the volume was, multiply it by 8. So I'm just going to write a quick reminder here. Just remember to cube your scale factor, whatever that is, for volume. If it was area, you wouldn't cube it, you would square it. And then if it's just normal dimensions, you would just not do anything to them. Okay, and again, there's an activity. We skip the activity and we go straight to the example. Here's example number 1. A cube with a volume of 64 cubic meters is scaled by a factor of 5. So k is equal to 5. What is the volume for the modified cube in cubic meters? So it explains it here. When the sides of the cube are scaled by a factor of k, the volume increases by k to the 3. So what you're going to do is you're going to take that 64 and you're going to multiply it by 5 to the 3. 5 times 5 times 5 is 125. 125 times 64 is actually a very large number. It's 8,000 cubic units. That's your answer for that. Okay, we're almost done. There was, I don't think, any other examples, because I labeled it example number 1, but I don't see another one written on here, so that should have been the last one. And then we get to summary. So the summary says, if all 3 dimensions of a pyramid increase by a factor of 2, by what factor does the volume of the pyramid increase? We just talked about this. So if the scale factor is 2, you just take 2 and you put a 3 on it. So it's going to be 2 times 2 times 2, which is 8. So your volume is going to get multiplied by 8. So whatever the volume was, multiply it by 8. Okay, so this one was a little bit shorter, under 20 minutes. Again, I'm going to email these, include them. Once I upload both videos, my Algebra 2 and my Geometry, I'll include both of these in the emails. And I will also include the formula sheet again, but again, it's the same one. So if you already downloaded it, already printed it off before, you do not have to do it again. Okay, so log in. Try to do the tutorial, try to go through there, and then hopefully this helped a little bit, and now you can try to do the mastery test. Shoot me an email or use the Remind app. Some people, again, have been communicating through there. I do try to check my email daily, so I should respond to you within 24 hours. And again, I'm not adding on to it. I just want you to keep going. The material that I gave you to do, some of it is difficult, so I expect people to still, keep going on it. If you have not started on it, you need to start on it. You're getting behind. You're already behind. And when we come back, it would just put you at a worse shape than anybody else. Okay. I will see you in the next video, and I will email you guys once this is up and running so you guys can log in and see that.